Alright, solving equations with variables on this side. Alright, we talked a little bit about this yesterday, so let's get into the examples. You got to use your rules in your steps. So the first example is 8t plus 5 equals 6t plus 1. Alright, so now you have like terms, but there's an equal sign between them. The only way to get them on the opposite side is to use rule 1. Rule 1 is adding or subtracting something in an equation, but you do it once on each side. So I'm going to put this 6t over here with the 8t because that'll give me a positive number. It doesn't always happen that way. But I'm going to move the term. To move the term, you must either do the opposite or add the opposite by adding. Okay, so I'm going to subtract 6t. So that gives me 2t plus 5 equals 1. Now I have a two-step equation. These two terms have to get together. I'm going to subtract the 5. 2t equals -4. Step 3, divide by 2. So t equals -2. Do you understand?
Yes.
Okay, solving stuff should already be second nature to you by now. So let's just work on getting like terms together across the equal sign. Do not mix this up. If you have like terms on the same side, you just add them together, right?
Yeah.
Or subtract them depending on what the operation is. But to move it across the equal sign, you got to introduce the opposite. All right, so 9a equals 6 times the quantity a plus 4. Everybody try to do this. What do you think we should do? Consider we just had that question about parentheses. What do you think we should do at this point? Sophie.
Distribute the 6 to
And why not just divide off the 6?
because you can't divide 9a.
Right, you'll end up with a fraction. Okay, so let's go ahead and distribute the 6 first. And you can divide off the 6, just you'll have to deal with fractions at this point. All right, so that's 6a plus 24. Now what do? I need to get my a's together. Sophie.
Subtract 6a.
Yeah, let's subtract the 6a. We already have an a by itself over here, so let's move this one to this side. So that's a positive 6a. I'm subtracting because that's positive, not because of that plus sign. Remember, the plus sign is attached to the 24. Subtract 6a. So 3a equals 24. Now what, Sophie?
Divide by 3.
Divide by 3. A equals 8. Okay? All right, so let's do another example. Example 3. Let me try this. 40 plus 14x equals 2 times the quantity -4x minus 13. Go ahead and try that. How do you want to start? Nathan.
You want to distribute the 2 to -4x and 13?
You could distribute the 2. You also could divide off the 2, because the other two terms here are both even. You can do it that way first. But I assume, did anybody, who did not distribute? Okay. You divided? You guys divided first?
No, I did something different.
What did you do?
I subtracted the 14x.
And put it over here? And where'd you put it? With this one or over here?
This one off the side before I.
And then you distributed?
Yeah.
Okay. So technically you're doing this. Alright, so 40 plus 14x equals negative 8x minus 26. Okay? What?
Oh, that's negative.
So this time, I would actually put the 8x to the left so that it would be positive. It doesn't matter, you get the same answer. So I'm going to add 8x to the left. So I get 40 plus 22x equals negative 26. Subtract the 40. 22x equals negative 66. Divide off 22. X equals negative 3. Did I got that right? Good. Alright, let me see if you can do this one since you're starting to catch on. Example 4. 2 minus 15n equals 5 times the quantity, negative 3n plus 2. Alright, let's see if you can do that one. Kind of the same as the last problem. How are we doing?
Actually, it looks kind of impossible right here. Yeah, it looks like that.
I just not guess.
It looks like it can't be true to me.
Why?
Because I got 2 equals 10.
Yeah.
2 equals.
I
That's
had
what
that
I
in there.
got,
I was
and then
like,
I just stuck it in N because
Yeah, I was
I didn't
like,
know what
I
else
don't
to
get
do.
So you just
I put,
magically pulled something out of your rear end and put it up in the problem.
well, if you have
Oh,
I just 15, negative 15 and plus, because I add the opposite. So
So
negative
here's what Sophie's saying. Sophie's a professor. She's going through here and she says, okay, that's how to distribute the 5. Did you add this 15 or add that one? Which one did you do?
I added the
You're not Sophie.
I added the one on the right, but I probably should have done the one on the left.
Okay, so Sophie's a professor today. She's saying let's add 15n to both sides. Okay, and then you got what?
2 equals 10.
2 equals 10. And so she says, well,
Let's do plus N on 2.
now let's just make a miracle here. Okay, now we can solve the problem. Okay, you can't do that. So she's this professor at a great college, and she says, then a miracle happened. Right?
Yeah.
And voila, we
And
have
that's
nuclear
math.
power. So, no, this is, most of you said not possible, you would say no solution. Obviously 2 doesn't equal 10. That's an example of no solution.
Yes, so I got it right.
I saw it on.
No, Min
You
did
got it
the
right.
same as me.
Whoa, I did.
Half of you. Okay.
I didn't do it.
Alright, did you get 2 equals 10?
Yeah.
Everybody got 2 equals
I
10?
tried to trick them.
Yes.
I would try to trick you.
You try
It
to
is
make
possible
us
that you'll get
plus N.
a not possible problem.
It is possible to get
It's
off.
possible.
Miracles can happen.
It is possible.
Example 5. 3x minus 9 equals 3 times x minus 3. Again.
Oh, are you kidding me?
What the?
Yes.
What?
Just put true. I'm just gonna put true.
What?
Yeah, true.
Wait, what? I don't get it.
Alright, so let's distribute.
What?
That's 3x minus 9. So if you got to this point
X can equal.
and you didn't understand what was going on, and you kept going, you said, well, I need to put these together, let's subtract this one.
X is 1.
And you get -9 equals -9.
And then you just add X.
And you're like,
Sophie said.
well, yeah, and then you
Then
just,
a miracle
a
happens.
miracle happens.
What the heck? Infinite.
Yep, that's what I was thinking.
Or you say, like some of the books will
Mr.
say
Lockwood,
this,
you're so
infinitely
smart.
many. Infinitely many. Okay.
Can we just put the
Oh,
sideways
I'm
in?
sorry. Yeah, infinitely many. But it's all, I want you to call it the identity.
What do we call
I like that.
it? Just say
Yeah.
identity. Okay.
Well, doesn't that equal that?
Yeah.
Isn't that the identity property?
Yeah.
Oh yeah. Wait.
Yeah,
So we just say identity.
yeah.
What do we put for no?
That means there's infinitely many solutions.
Is there any rule for no solution, or is it just no solution?
Read that one.
So there is a solution to that.
There's infinitely many. Anything you put in for X is gonna give you the same answer. Give you
The right.
answer.
You can put a 0.
Right? If I put 1 in, don't I get 3 minus 9 is 6, -6? 3 minus 9 is -6. Put 2 in, okay? Anything you put in for X is
Yeah,
gonna
you
work.
could get pi.
Yeah.
If you did pi.
Assignment, page 157, 4 to 42 evens, mixed review.
I've already.
Not even.
Not
Wait.
Got one?
Wait,
Waiting.
Tonkin.
Yeah, buddy.
Wow.
Yeah, go Mr. Lockwood.
I wish you erased the 4 to 42 evens and just kept mixing it up.